Guys, we're back at the TVM Solver, and this time we're going to talk about saving money where there's a regular deposit, a regular monthly or annual deposit, or regular payment, a payment into the investment account. So here, Amy is a 25-year-old and has attended some retirement planning seminars at work. Knowing she should start thinking about retirement savings early, Amy plans to invest in an annuity that earns 5% interest compounded annually. She plans to save $100 from her paychecks each month so that she can make one annual payment of $1,200 into that annuity. Using the TVM calculator, let's determine the future value of the investment after 35 years. So let's open up our TVM Solver, Finance Solver in the calculator. And let's look at this investment account that she's dealing with. First, we see that the interest is 5%. So we can go ahead and change the interest to 5%. She plans to save $100 from her monthly checks so she can make annual payments of $1,200. So we're making payments of $1,200. Now, the important thing to remember here is that present value and payment need to have the same sign. They both need to be positive or they both need to be negative. And remember, present value and future value, present value PV and FV, need to be opposite signs. So whatever sign the payment is, you're going to get the opposite sign for future value. So we need to continue on. It says here that the interest is compounded annually. That means this PPY and CPY, the payments per year and the compound periods per year, is 1 because annually means once a year. And then we need to see that the time in the last sentence here is 35 years. So for N, we're going to take 35 times 1, and that's going to give us our N. We now have everything that we are given because in this paragraph, it does not say that we have a present value. So present value needs to be 0. And I'm going to make payment negative. That way, our future value will turn out to be positive. So I have everything entered that I need. Press enter, and then I see that in my 35 years later, I'm going to be making $108,384.37. That is my future value of my annuity if I pay $1,200 a year. So let's take a look at Amy finding another annuity and seeing if we can figure out what she's going to end up with there. Here she finds another annuity that accounts for monthly compounding and monthly payments. The annuity pays 6% interest, so let's change the interest to 6%. It's compounded monthly, so I'm going to take 12 times, well, in this problem, it looks like 40 years. That changes to 480 for my variable N. Again, I don't have a present value. I'm not depositing any money at the beginning. I'm only making regular monthly payments. But I don't know what those payments are because the question says we need to have $850,000. And then my payments per year and compound periods per year needs to be 12. And I need to calculate my payment, my regular payment each month to figure out how much it will take to get $850,000. So when I press enter, I see here that each month I need to save $426.82 in order to make sure that 40 years later I have $850,000. Guys, that is saving money, investing money, but this time making a regular payment.